In this demo, we'll explore how F5 Big AP application security can be used for validating API calls. We will look at why OpenAPI OES schema validation is important and how it can be configured through Big IP Service Portal. Then we will move on to an advanced scenario of updating the API schema through automation as the app evolves. APIs introduce an expanded attack surface for unauthorized access, data exfiltration, and other exploits. According to a recent report, the rate of delivery of new APIs to production is accelerating from weeks and days to hours. This outpaces many traditional security processes, underscoring the need for a robust, flexible API protection measures. F5 provides comprehensive security solutions that can be deployed as an on-premise appliance, a cloud service, SaaS offering, or at the customer edge. All F5 models leverage a powerful attack signature engine, and Big AP provides a flexible platform for application security, including API schema validation. One of the most effective ways to secure an API is by validating each request against an OAS schema, which defines all allowed routes and parameters. In this demo, we'll showcase two approaches using F5 Big AP. The first is a SecOps-focused method, where a security policy and the OAS schema are manually uploaded via the Big AP Service Portal. The second extends this concept with DevOps automation, which triggers schema updates whenever the application code changes. In this demo, we will do three simple things. 1. Upload the specification schema. 2. Define some paths and a wildcard URL in our configuration. And finally, we will check to make sure that the policy is working. In the service portal, let's create a new policy and select an API security policy template to begin. Give it a policy name, followed by a description if necessary. And this is where we upload the OAS file. In this case, it's Swagger output in the YAML format. We can also select the virtual server that this policy will be assigned to. The uploaded schema will automatically create a list of allowed URLs and parameters, which we can see here. However, in order to block all of the other parameters outside of the schema, we need to create a wildcard entry under the disallowed URLs. That way, all of the requests outside of the schema will get rejected. Now that the URLs are created, we can make sure that all policies apply to our virtual server. Here in the summary view, we can see that is successfully applied. Now let's test this policy by issuing a curl request to a disallowed URL, followed by a legitimate API call to a route that is allowed. And as we can see here, the first call is blocked, while the second returns the correct response from our API service. So we have successfully added API validation using the Big AP Service Console. The same flow can be easily automated using Ansible playbooks, which is illustrated here. SecOps or NetOps can run a script to read and upload a schema file with an associated policy with just a few lines of automation code. And of course, we can extend playbooks to handle multiple TMOS instances or different APIs, all within the same workflow. Now, let's extend this use case to address a common GitOps scenario where an API schema should be updated in Big AP as soon as the production app code is updated as well. In this demo, we'll showcase how DevOps can leverage an OAS schema stored and updated in a Git repository to enable automated updates to our WAF whenever the API changes. The key piece to this is the continuous integration, continuous deployment, or CI/CD environment, which triggers a pipeline after a code or schema updates. Using the Jenkins server as example, when a change is detected, the pipeline is triggered to build and deploy the new code, and in parallel do the same for the OAS file upload into the WAF. This ensures the security policy is always in sync with the latest API definitions. By integrating the OAS file into the CI/CD pipeline, teams can maintain consistent protection without manual intervention. To demo this, we'll build on the previous example by first running an API call that shows that the schema version is currently at v1. Next, let's perform several operations on the Git repo, which contains both the code and two versions of our sample API service. We can see here that in the main branch, when we check it out, we can just replace scriptroutes.js file with a new version, v2, which adds a new route to our API, and then commit these changes. This code commit will automatically trigger a Jenkins server job. In the Jenkins UI, we can observe the pipeline executing a set of Ansible playbooks. These playbooks perform two main tasks. The first one, building and deploying of the application, including dependencies configured by the app and API developers. And second is generating Swagger definitions for version 2 of the API, which is the OpenAPI schema file. Then it gets updated in the WAF using a playbook that was similar to what we did in Demo 1. When the CI/CD pipeline finishes, we run the same curl request as before and see that the Swagger file version has indeed been updated from V1 to V2. So this just highlights how quickly and seamlessly the GitOps approach can be used for keeping your API security in sync with the evolving application and API logic. So one takeaway is that by merging API security into a GitOps workflow, you can shorten release times and reduce operational headaches. Another takeaway is that F5 BigAP provides the service portal, the APIs, and the automation to solidify compliance initiatives by safeguarding APIs using schema validation. Learn more how you can effectively manage your API security posture by using BigAP today.